Imagine a city, not on Earth, but floating in the silent darkness of space. This is the International Space Station, or ISS, a gleaming structure with vast solar panels orbiting our planet every 90 minutes. It's humanity's outpost in the cosmos, a home, a laboratory, and a beacon of hope. The ISS is larger than a football field and weighs nearly 1 million pounds, yet it glides with impossible grace. Hurtling at 17,500 miles per hour, astronauts aboard witness 16 sunrises and sunsets each day. From 250 miles above, the view transforms our understanding of Earth. Weather patterns swirl, city lights trace civilization, and the thin blue line of our atmosphere is visible. The ISS is a joint project between NASA, Roscosmos, JAXA, ESA, and CSA, a true symbol of international cooperation. Life here is unlike anywhere else. There's no up or down, and you float from place to place. Even drinking water is a challenge, as liquids form floating spheres. The astronauts are pioneers, living on the edge of the human frontier. They conduct experiments, maintain the station, and experience a reality most of us only dream of. The ISS is not just a machine, it's a testament to what we can achieve together. It's our eyes and ears in space, offering a perspective that unites us all. This city among the stars is a reminder of our shared destiny, and it's only the beginning of our journey beyond Earth. How does the massive ISS stay in orbit? The answer is a delicate dance between speed and gravity. Gravity is still strong at the ISS's altitude, about 90% as strong as on Earth's surface. The station isn't just floating, it's constantly falling around the Earth. Imagine throwing a baseball so fast that as it falls, the ground curves away beneath it. It never lands. That's orbit. The ISS's speed, 17,500 miles per hour, creates continuous freefall, or microgravity. Everything inside, including astronauts, floats because they're all falling together. This weightless environment is what makes the ISS a unique laboratory. But the orbit isn't perfectly stable. Even at 250 miles up, traces of atmosphere create drag, slowly lowering the station. To stay aloft, the ISS gets periodic reboosts from its own thrusters or visiting spacecraft. These maneuvers keep it circling Earth, maintaining its delicate balance. Without them, the station would eventually spiral down and burn up. The ISS's graceful orbit is a triumph of physics and engineering. It's a city in the sky, always falling, but never landing. And that's what keeps it afloat in the ocean of space. The ISS wasn't launched in one piece, it was assembled in orbit, piece by piece, over more than a decade. The first module, Zarya, launched in 1998, followed by the US Unity node, joined in a carefully choreographed space ballet. Over 40 assembly flights and more than 200 spacewalks were needed to build the station. Astronauts working in bulky suits and extreme conditions became space construction workers, bolting modules and connecting cables. American space shuttles and Russian rockets delivered key components, each fitting perfectly with the last. The logistics were staggering, involving thousands of people from 15 countries. Every new piece was meticulously planned years in advance. The result? A sprawling, functional outpost built by the combined ingenuity of humanity. The ISS stands as one of our greatest engineering achievements. It's a skyscraper in orbit, built by hands from around the world. The ISS is a collection of interconnected modules, each with a unique purpose, like neighborhoods in a city. There are two main sections, the Russian orbital segment and the US orbital segment, each with its own systems. The US side houses labs like Destiny, Columbus, and Kibo, where groundbreaking science happens. Kibo's airlock and robotic arm let it deploy experiments directly into space. Nodes like Unity, Harmony, and Tranquility connect modules and serve as docking points. The cupola, a 7-windowed dome, offers breathtaking views of Earth and is a hub for operating the station's robotic arm. The Russian segment provides life support, propulsion, and living quarters. Docking ports welcome visiting spacecraft, keeping the station supplied. Together, these modules form a true international city in orbit. The ISS is powered by the sun, using enormous golden solar arrays that stretch wider than a football field. These arrays capture sunlight and convert it into electricity, generating up to 120 kilowatts, enough to power over 40 homes. When the station passes into Earth's shadow, rechargeable batteries provide uninterrupted power. The solar arrays rotate constantly, tracking the sun for maximum efficiency. This system keeps the station running day and night, powering everything from life support to scientific experiments. The array's silent rotation is a marvel of engineering. Without the sun's energy, life on the ISS would be impossible. Solar power is the lifeblood of this city among the stars. It's a shining example of sustainable energy in the harshest environment. In space, survival depends on creating an Earth-like bubble inside the ISS. The Environmental Control and Life Support System, or ECLSS, provides clean air, water, and a comfortable temperature. Oxygen is generated by splitting water molecules using electricity from the solar arrays. Carbon dioxide is scrubbed from the air, and some is recycled with hydrogen to create water, a process called the Sabatier reaction. Water is precious, so the station recycles about 93% of it, including moisture from breath, sweat, and even urine. Advanced filtration turns wastewater into drinking water, cleaner than most tap water on Earth. This closed-loop system is vital for long missions and future exploration. The ECLSS is the unsung hero, making life possible in the vacuum of space. It's a model for sustainability, both in orbit and for future journeys. Without it, the ISS would be uninhabitable in minutes. The ISS is a busy port, welcoming spacecraft from around the world. Docking requires precision. Some vehicles dock automatically, others are captured by the station's giant robotic arm, Canadarm2. Astronauts use Canadarm2 to grab and berth visiting cargo ships, guiding them safely to the station. The arm also moves equipment, assists spacewalks, and performs maintenance with its two-armed robot Dextra. Canadarm2 is the station's workhorse, enabling complex operations outside the station. Every arrival is a cosmic handshake, connecting Earth to its outpost in space. The ISS thrives on these regular visits, keeping it supplied and operational. It's a hub of international collaboration, made possible by robotics and teamwork. The ISS exists for science, a unique lab where microgravity unlocks discoveries impossible on Earth. Studying the human body in space reveals insights into bone loss, muscle atrophy, and disease, helping patients back home. Scientists grow perfect protein crystals and create new materials, advancing medicine and technology. The station's instruments monitor Earth's climate and disasters, while others search for dark matter and probe the universe. Every experiment adds to our understanding of life, matter, and the cosmos. The ISS is a platform for innovation, shaping our future on Earth and beyond. It's a floating laboratory, pushing the boundaries of science, and every day, it brings us closer to new frontiers. For over 2 decades, the ISS has been a symbol of human cooperation and achievement. Astronauts from around the world live and work together, building trust and sharing knowledge. The station has taught us how to survive and thrive in space, preparing us for future missions. Lessons from the ISS, like recycling water and robotic repairs, are paving the way to the Moon, Mars, and beyond. As the ISS nears the end of its mission, its legacy will continue through new stations and lunar outposts. The Artemis program and the Gateway station will build on what we've learned here. The ISS proves we can live and work in space for years at a time. It's our first true home among the stars, a cathedral of curiosity and ingenuity. The journey doesn't end here, it's just the beginning. The ISS is our stepping stone to the cosmos.